Welcome back, nerds. Sorry, geometers. Geomenerds? Oh. All right, I have a quick question for you. Get 1 minute to decide. It snows here. Okay. My question for you is, as a class, you get 1 minute to come to a consensus. I'm going to call on one of you 8. Do you guys know where I live?
Yes.
A block that way. Like literally right on the other side of the school. It's 60 seconds for you to walk to the school, which is awesome. I want to know on which date is going to be the first day that I walk outside of my house at 7:30 when I leave for school, and I step on the sidewalk, not my porch, not the grass, the sidewalk, and I can leave a footprint in snow. Not wet slush, it needs to be white snow. It can be the little white Dippin' Dot pellets snow that we get early in the year, but I want to know, this class thinks what date is going to be the first day that I can leave a footprint. As a class consensus, we'll record it, talk it out, decide as a class. First day of snow with enough snow for a footprint, go, 1 minute. So, here we are. Yesterday we talked about this stuff. I don't want to talk really anymore about this. We're trying to figure out the pace. Hopefully it feels a little faster this week than it did last week. We're getting close to being at the right speed. Yesterday was the first day of this, right? Yeah. This is, according to my book, it's supposed to be a 2-day lesson, and we are going to knock it out. So, for this, we're going to see this over and over and over with different sections as we learn new terms and stuff. I will stick with this green color. We're going to work within this congruence section, right? Bullet point is my main section. Our first little subsection, we just have some properties. So I need to see if your book calls this a theorem or not. I don't care. We're just going to call it congruence, which, am I going to write the word congruence? No. Nobody has time for that. What am I going to write instead of the word congruence? So check it out. We have some congruence properties. Again, I'm lazy. Props is short for what?
Properties.
Properties. That sounds reasonable. So I'm going to check. I don't really care a ton. That's not entirely true. I care more that you're able to do it correctly than you are to be able to use the right word. But I think they're both important because if we want to talk about math, we need to agree. You are going to see 3 properties. I'm going to list them horizontally to save a little space in your notes. Cool. We have 3 properties. We have the reflexive property of congruence. Reflexive, not reflective, with an X. The reflexive property. Okay, I'm actually going to do 2 horizontal and then I'll do 1 underneath because there's one that's longer to write. We get the reflexive property of congruence. We are going to get the symmetric property of congruence. And I'm capitalizing these not because we're going to formally define them with like a sentence or anything like that, but these are properties that will just have the definition be how they work. And the last one is this idea of the transitive property. Now, in the interest of saving a little space, just so you guys know, if I wanted to be really formal and hardcore, I would have written the reflexive property of congruence. I would have written the symmetric property of congruence and the transitive property of congruence, but I think that that's not necessary. All right, how many of you guys remember just 1, 2, or 3 fingers? How many of these words do you remember seeing? Okay, some of you, 5 of them?
But we were supposed to count.
1, 2, or 3 of them.
Oh.
Boom, okay. Onesies, which one? Like, just which one do you remember seeing?
Symmetric.
The symmetric property. Cool. Everybody remembers seeing it, mostly. What is it?
The same.
When they're the same, so but like when you fold it, if you're not folding it, it'll be the same.
Maybe. What do you mean the same? Like, what would I write here that I would fold?
It'll be symmetric.
Like, give me an example. What could I write?
The letter U.
U?
And if you fold it right down the middle.
So that does have symmetry. I agree with you. Like parabolas do, right? Or squares have symmetry. You're on the right track. If I write this one, let's say hypothetically I make the claim and I'm choosing, I can do segment, I could do angle. Doesn't matter. I'm using segments right now. If angle AB is congruent to segment CD, and I'm pretty sure I said angle AB and then I wrote segment, so my bad. Segment AB is congruent to segment CD. Now, we're going to learn some shorthand today, and it's real shorthand, it's not just Holloway shorthand. We are going to use this symbol all the time this year. Anybody remember what this symbol means?
Goes to.
Implies. Now, goes to is logically going to be essentially the same. Another way you may see this is then. It would say if AB is congruent to CD, then, and that could be implies or then. All right. Any guess on what's on the other side of it?
A, B, and CD.
So not quite. I mean, yes, but not in that order. Turns out that CD is congruent to what? AB. Now, Lily, depending, and this is why I was asking what do you want me to write, because you know the idea of symmetry. It's just saying if, like normally, just purely because of the way we learn it, when you solve an equation, do you put 5 equals x or x equals 5? Normally you put x equals 5, knowing that the other way still works, but it's unnatural because we stick with 1, but it's allowed. That's all this says. You can switch the order. Okay, the reflexive property. This is going to seem like a dumb question. Andrew, guarantee without a doubt, can you tell me an angle that A is congruent to? The same shape and the same size as? Gut feeling.
Square.
Maybe. So we'll talk. We'll get there. It could be a square angle. Anybody else? Something obvious without ever knowing what the angle looks like. B, maybe. This one feels silly. I think of the word reflective. Is angle A the same shape and size as angle A?
Yes.
It seems so silly to write down. This is the reflexive property. We will use this. Like, I know it seems like, well, duh, why would you ever worry? We'll see it. Yep. Everything is congruent to itself. If I did it with a segment XY is congruent to what? XY, segment XY. Yeah, they're the exact same. Okay, now, because these properties work with congruence, if I wanted to say the measure of angle A equals the measure of angle A, is that also true?
Yes.
Yeah, because them being congruent, that's what it means. Okay, transitive property. We're going to write an if-then statement, but we're going to use the words if and then rather than this. Okay, we're also going to learn some shorthand while we do it. Okay, check it out. I'm going to do the shorthand first, and we'll make it the wordy version. You want angle or segment? Segment. Okay, that's twice as much writing. Let's say AB is congruent to BC. And then here's a real shorthand, not a Holloway, just a real one. And. This is a real symbol. And. Nope, you're wrong. Okay. AB is congruent to BC and BC is congruent to CD. What does this one mean again? Implies or then, either way. I'm going to write then because it's shorter. What do we conclude? Somebody's going to be able to... I just pinched my arm so hard. No. I'm going to cry. I'm not probably really going to cry. What do we conclude? Talk it out, neighbors, quietly. Pick somebody to talk. Neighbors. Okay, so high key, ask. Like, if you don't know, this class is going to suck, man. Cool. Check it out. I'm going to give you a different one, a little more like algebra.
AB equals CD?
Not equals.
Congruent to CD.
If I say AB is the same as BC and BC is the same as CD, logically, do you agree that AB must be the same as CD? This is the transitive property. Now, the only other thing, if we wanted to, and I would prefer to use the symbols. I think it's easier. Only thing that would change is we'd write if, this, and this, then this. That's it. Okay. These three properties are going to show up all the time. When we start writing proofs here in a few days, we will have shorthands. I use trans. Okay. Like that's my shorthand. Sim is my shorthand here. Refl is my shorthand here. REFL. Yep. Cool. We'll get used to it. These properties seem reasonable. All right. So here we go. We have two examples, and we're just going to do some constructions, and we'll call her done. So here we go. I want us to get a little practice using congruent figures. Example, use congruence. And we're going to use congruence as it's presented either written or by the marks on an illustration, whatever the case is. Now, this is always my least favorite part of geometry. Drawing the examples. No, I know grading sucks always, but drawing the examples. If you guys would like, I have no issue giving you a printout with some of these examples on it, but if you're using a notebook, it's a nightmare to try to keep it in line with your stuff. Let me know either way. Like, we can draw them. It just takes a little time. I'm going to use some editing magic to save some time on the video itself.
What does the arcs mean?
What do the arcs mean again? Do you have notes in front of you?
Yeah.
What did the arcs mean on the angles yesterday?
I didn't write it down.
I think you did, because I can see it on your page. Check it out. We said that N was what to E? Angle N and angle E were what in your notes? If you look right above.
Oh, they're the same.
Give me a better word.
Congruent.
Good. Okay, here's a question. Together as a whole class, or together with your neighbors, and then I'll work it and we'll compare.
So the arcs.
With whole class, or, okay, all right. So, I'm fine with that. I know how to do this problem. I imagine you guys probably do too, even if it doesn't feel like it. But here we are, I'm stuck. Oh no, this sucks. What do you want to do, number? Gosh, my calculator, I keep forgetting over here. Anybody in wood shop? Not right now, this is.
80,
You are? I might commission a project from you. Why didn't you sign up? What do you mean, I wish? You had the option, didn't you? Okay.
87.
Again, I just want to stress, because I can feel the tone. My tone always just sounds sarcastic or snarky. I'm not being snarky. I mean, maybe a little, but. All right, I'm stuck, but the good news is number 3 can help. I don't know, any idea? Who's number 3?
Oh, I think that's.
Camille! Wait, what?
I'm pretty confident that's
You're 3?
me. Yeah.
Camille's 4.
Camille is 4. Number Harbor. What would you like to do first? I'm gonna switch colors for anything that's additional.
I know how to do it. I guess you could do 151 minus 60. There.
So,
Minus, or you could do angle ABC minus angle ABD and angle EBC, which since they're congruent, they're both 32.
I'm gonna pause you real quick. I agree with you, but I want to check something. Anybody else lose track of the angles just now while he was saying them? This sucks about geometry. Naming them is not fun. I have a workaround. As long as you draw it on your picture and I can identify what you're talking about, I'm always cool with it. How many angles, different angles do we have up here? Like
3.
alone. There's more than 3 angles total, but there's really 3 that we see. Here's what I would like to suggest. Instead of angle ABD, angle 1, angle 2, angle 3. Let's use these to talk about it.
Okay.
We'll write way less. Now, I agree with most, like everything that you said, but I want to be a little bit clearer. What did this mark mean again?
They're congruent.
So if this is 32 degrees, what is this?
32 degrees.
So even though it's angle 3, and I'm going to put it a little bit further down, do you guys also agree that this is 32 degrees?
Yes.
Okay. Now, I would like you to get in the habit, especially because we're going to proof. I have a few shorthands that I use. Okay. Check this out. If I were to add up the measure of 1, 2, and 3, do we get ABC, the big angle? If I take this little angle and add this one and this one, should I get the measure of the big angle?
Yes.
Okay, now instead of writing measure of angle over and over, which I will this time, but I'll show you a proposed shorthand that you're welcome to use if you'd like. Okay, I know right now that if I take the measure of angle 1 and I add it to the measure of angle 2 and I add it to the measure of angle 3 again, what larger angle do these form?
151.
So don't give me a number yet, we'll get there. You're right, just so you know. ABC. This is just to save time. Now, because we've named them 1, 2, and 3, it's not as big of a deal. If you would like, I'm going to show you something optional. If you want to use it, if you want to write it, but this gets tedious to me, writing this over and over. So oftentimes what I will do instead, and I'm sure I'll do this on the board, is I'll say the measure of angles, 1 plus 2 plus 3. And then it's almost like it would just distribute. If you would like to do this, you are good to. I'm okay if you do this on quizzes, homeworks. I will try pretty hard to do this up on the board in class. This is a time saver. As long as you put the brackets, it's like it distributes. All right, anyway, let's keep rocking. What is the measure of angle 1, number 7?
32.
It is. So I'm just going to substitute right here. Angle 1, 32 degrees. Plus, what's the measure of angle 2, number 1? Well, measure of angle 2, we don't know it. So Harbor suggests calling it x. We could, but if we already have an unknown, can I just call it this? Yeah, if you want to call it x, you can, but I'm just going to keep it here. We don't have to write a ton. Andrew, what's the measure of angle 3? It is indeed. And Raylene, what do they all add up to? The measure of angle ABC?
151.
Indeed. Okay, welcome back to like 7th and 8th grade algebra prep stuff. Can you guys solve this for the measure of angle 2? Prove it. I'm gonna give you a second. Talk it out. If you have no idea, like you say yes and you're really not sure, let me know. I think everybody in here can do it, but I'm here to help. Your neighbors are here to help. We're all here to learn and be successful. Let's do it. Okay, I'll give you a little bit of time. What did I do to go from this line to this line?
Added,
Combined like terms, and I added 32 and 32. If you have to use a calculator, I don't care. Like your ability to multiply and stuff, we're not going to do any mad minutes or anything in here unless you guys really want to and love them. I loved mad minutes when I was little. But check it out. I do not do algebra. We do the same algebra. It looks different. How many of you guys draw balance? So check it out. How many of you guys have the power of imagination? Everybody can imagine something. You guys physically draw balance every time you solve something, yeah? I don't. I don't either.
I hated drawing balance.
Yep, I don't. If you don't want to draw it, don't. If you do, do. If it helps to make sure that you do the same thing to both sides of the equal sign, continue to do it. I won't, just so you know. Okay, so here we are. I want to solve for the measure of angle 2, but I'm adding 64 to it. What undoes, or what's the opposite of adding 64?
Minus 64.
So I'll subtract 64 from which side?
Oh,
Both sides of the equal sign. I will try really hard to remember to always show this work, but inevitably it will happen where I don't write what was in red just now, and my next line is just this. Gosh, 151 minus 60 is 91, right? And minus 4 more looks like 87.
yes.
87 what?
Degrees.
Degrees. So, did we really just solve our problem?
no.
I'm going to put the 87 degrees here. Were we after DBE?
Yes.
Yeah, but I could have just as well asked you about ABE, right? Angle Alpha Bravo Echo. And we would have then had to combine one more time. As long as you know what these marks mean, we're not going to get anything wild and crazy today. Would you like to try another one?
Yes.
Okay, for this one, I'm going to be lazy because I have it drawn in mind. I don't have the answer. I don't know what the answer is, but we'll find it. Here's B. I have point Q, and then I get QN, QP, QR. Whoa, I have point O. I'm sorry. I hate that I used O. O is this one. Then I have ON, OP, OR, OQ.
Is,
This is an O, and this is
I know.
PQR.
It can't.
It's an O.
Yeah, I was
Yep.
gonna say it can't be a Q.
O and O.
Okay.
Sorry about that.
A little confused.
Cool. Really rough sketch.
Are we trying to solve that?
Yep, I want you guys to do this one. I'm going to copy this just so I can fix that.
Partners or-
Yeah, independently or with your neighbors. I'm good with it. Word to the wise though, if with your neighbors, if you feel like sometimes it's your neighbor does it and you don't really ever learn anything, don't. Like, do as much of it as you need to. O,
Are there both Q's?
so that's what it would look like, and that's what I wrote initially, but these are O right here. My bad.
Would we combine NOP and POR?
That's a great thing to try. If you're wrong, that's okay. Try it out. I'm going to give you guys about 2 minutes. I want to see what you come up with, and if there's issues, we'll find out where they are and we'll fix them. Vi. Okay. The drawings help. There's a reason that we draw them. Now, I'm looking for X, and it's in here. Cool. NOP is this angle right here. Now, it doesn't have something it's congruent to, so if I want to make sure that it's really clear what angle I'm talking about, I can't use one arc because that would make it look like they're congruent. So if I want to make it really clear that I'm talking about this angle, I will add these, even though there's nothing that says it's congruent to. What do I write on the interior of this angle?
2x plus 2.
I would agree. 2x plus 2, and there should be degrees. Your book is really not great about it, but 2x plus 2 degrees. Okay, what about POR? What do I write here? And golly, they did not give me ROQ. Bummer. Shucks. What do I write on the inside of it?
3x minus 5.
But that was POR.
Kangaroo.
Oh, they're congruent. Look at that. Okay, now we're cooking. Now, there's one more little thing that I would add to this illustration, and I think I helped a couple people add it. Do we know anything else? I know the whole angle. So if I write 114 right here, hypothetically, what does it look like I just called 114? It looks like it's ROQ. How on earth could I draw it and put it on my page so I can see it clearly? I don't know what to call this symbol. I'm open to whatever you guys want to name this. What do you call this? It's kind of like an arc, a big arc? I don't know. I don't know. Hold on. Noah? Right? There's a story. There's a joke in there. Yep. All right. He had an arc.
Yeah.
And it was big. Yeah. Are religious jokes allowed in school? We're going to make... Nope. We're just going to stop there. We'll stop.
Well,
All right.
It's too late now.
Yeah. Well, I was going to say,
Noah
to make
in
things
my mind.
equal, we better make another joke, but I don't know how other religions feel about jokes. Buddha, they're okay with it. All right. So here we go. Gosh, what do these three expressions have to add up to then? 114. So here we go. I'm going to write out maybe more than you did. If I take, and we could write the whole thing, measure of angle NOP plus the measure of angle, or could we agree that this angle plus this angle plus this angle is the big one? We're not writing a proof right now. I would like to not have to write all the angles. When we do proofs, we have to, but we're not proving anything. So here we go. If I take 2x plus 2 plus, I'm going to add this one twice, right? So I could write plus 3x minus 5 plus 3x minus 5. Totally good. Could I also, if I know it shows up twice, could I just write it like this? Is either way better than the other?
Yes.
I don't think so. Not really. You might think so. Like, you prefer one, I'm sure. But they're the same thing.
Well, I mean, what if you had 50 of the same angle? Then you could really see which one.
For sure, right? Yep, definitely. Okay, now, when we introduce it like this, the cool thing is we get this really fun algebra review. What's this called when I draw these?
Distribution.
Distribution. So let's just clean it up a little bit. 2x plus 2 plus, what's 2 times 3x? And 2 times negative 5? Still all equal to what? 114. Okay, now that I have it cleaned up and there's no more distribution or multiplication, I'm going to combine like terms. How many x's? 2x plus 6x is 8x. What's 2 minus 10? Negative 8. Still equal to what? All right, here's our algebra moment.
Oh, you have the plus 8.
Yeah, let's add 8 to both sides. Let's isolate the variable on one side. I will add 8 to both sides of the equation. If I add an 8 here, it's gone. It means just 8x's remains. What is remaining on the right side? And I'll go ahead and add this. 22?
120.
There we go. 122. Are we done?
Yep.
Almost. What does this say on the left? Good. I was expecting 8x, but it's multiplied by 8, right? What undoes a multiply by 8, or what's the opposite of multiplying by 8? Dividing by what? 8. Everything left side divided by 8, right side divided by 8. I'll do the left. It's x. Okay, just so we're clear, I will belittle you in a probably kind of mean way, but it's not like legitimately mean. What did I do? I won out. Did we already have this conversation?
Yeah.
Okay, good. 122 divided by 8. Let's see. That's 61 divided by 4, which doesn't work nice. That's 15.25.
Yep.
I have an answer.
Oh,
Oh, sorry. Wait, time.
I did it differently, but like I still came out with 8 eggs, and then Carson like told me that I would have to put on the equal sign and gone down. So was I like technically on the right track, or no, not really?
Wait, what? What did I
So
say?
how come you have, I like the 5x. So no. So, and love this. When we say you have to subtract 5, like that's a coincidence that we got the same number, just so you know. You have to, if you want to subtract 5, it has to be from both sides of the equal sign. You, like, if you don't have an equal sign in the thing that you've written, you cannot take something away from it. Always, always, always. Okay, we were after x. Now, I did not put degrees. Should I? Where up here do I say x is the angle? Nowhere. I say this angle is made up of something with an x in it. If you give me a degree symbol when you're not supposed to, am I going to destroy you? No, absolutely not. Okay. Are y'all ready to play with some straight edge and compass?
Yes.
Okay. Here's a weird thing. Do you want it in your notes? Do you just want it on a piece of scratch paper?
Scratch paper.
Okay. So I have a challenge for you. This is going to be weird. Your book has detailed directions with these that you can look at. But if we're just going to do them on scratch paper, I'm cool with that. So all I'm going to do, last little section here, we're going to give ourselves some constructions. And I'll give you guys graph paper or scratch paper if you'd like, but we're going to do some constructions. Now, what I would encourage is we'll just say what we're going to construct today, and then your book will have the detailed directions if you need it, but we will do it together. Okay, so there's 3 constructions that we're going to try to knock out today. If we don't get to them all, we'll finish the other one. I plan on giving you guys a little bit of homework tonight, but cool. 3 constructions. The first one, copy a segment. That's our first construction. Using only straight edge and compass. No measuring stuff. Okay, we're going to copy a segment. We will then copy an angle. And then I'm going to save the third one because we probably won't get to it today, and there's a vocab in there. If you want to know what's coming, it's going to be called bisect an angle. But if anybody know what bisect means?
Split into two.
2, okay. So close, a little bit more.
Like, put a line between the two.
So yes, that's cut into 2 still. If I bisect an angle, I cut it into 2 congruent parts. So it's like cutting an angle. If I have a 50-degree angle and I bisect it, I get 2 25-degree angles. Okay, here is some lovely scratch paper for us. What I want you to do is, using a straight edge, I want you to draw a small segment. Don't care how big it is. Some small segment using a straight edge. And I'll draw one up on my book. Sorry?
Second.
A segment. Yep. And we'll name it AB, for example.
Oh, never mind.
Okay. All right. These first ones are going to be a piece of cake, I think. And I'm going to do these on not here because I need a protractor. I'll do this. All right. I need a straight edge also. Love the little ones. All right. So I'm feeling crazy. Let's go ahead and draw a segment. Okay. Did anybody measure its length? Don't. Cool. Check it out. I'm going to draw a segment. Shapa. There it is. It's beautiful. I'm going to call mine AB. No idea how long it is. You good?
Yeah.
Okay. I want to draw another segment of the exact same size is my goal. Yep, on your scratch paper, just draw a segment. I called mine AB. You can call yours AB. Don't measure it. Just draw a straight line. It has to be a straight line. Use straight edge.
Straight edge.
Please put these back on the table when you're done. Did you draw that Friedman?
No, I drew it.
Oh, yeah, that also works. All right. Here's my challenge. I'm going to put another point right here. I'm going to call this C. I want you guys to walk me through the necessary steps to make segment CD that is congruent to this. I want another segment without you measuring the distance, because you're not allowed to measure because we're doing this the old-fashioned way without measuring devices. How do you make another segment that starts at C and ends at D that's the exact same size? I'm going to give you a play around with it for a second. You will use your compass, and we'll see if somebody can come up with a way to walk us through it.